Hello viewers, you are welcome to this video. Today I want to introduce you to absolute values. Absolute values. Viewers, the absolute value or modulus of a real number x is given by this. So when you write this, it means absolute value of x or modulus of x, where x is a real number. X, if x is greater than or equal to 0, and it's equal to negative x if x is less than 0. Yes, so the absolute value or modulus of a real number x is given by this. So when you see this one, it means absolute value of x or modulus of x, and this is the definition. For example, when you have to find the absolute value of 5, then from this definition, you see if x is greater than or equal to 0, then the absolute value is the number itself, is the x. Are you using it? So the absolute value of 5 will be equal to 5. The absolute value of 0 will be equal to 0. That's the first one. Are you using it? So if you have absolute value of 6, it will be equal to 6. Now, the second one means that when you have to find the absolute value of, say, negative 7, then it's equal to 7. That is negative of negative 7. Are you using it? And that will make it 7. If you are asked to find the absolute value of negative 10, then it will be 10. So what this simply means is that when you are asked to find the absolute value of a real number, you are interested in only the number there. Do you see it? Yes, ignore the sign and give us the number there. That's the meaning. Yes, so the absolute value of a real number x is defined this way. You can find the absolute value of any real number at all. Do you see it? For example, when I say what is the absolute value of negative 200, then it is 200. So what it means is that when the number is negative, then the absolute value is just positive. If the number is already positive, the absolute value is positive. If the number is 0, the absolute value is 0. Yes. Now, viewers, let's look at some of these things. So you should never forget this. This is the definition. You can give me something like this. Absolute value of x is less than, say, 5. You can ask you to solve for x. What are the values of x which will satisfy this inequality? You can ask you to do that. So, solution, when you are giving something like this, and solve for x, then what this means is that now, absolute value of x is x if x is greater than or equal to 0. So this means that x is less than 5. You see the absolute value of x here, if the x here is greater than or equal to 0, then the answer will be x. So this is the first one. Or if this x is negative, say negative real number, then its absolute value will be negative of the x here. So, or negative x less than 5. You can decide to divide through by negative 1 here. Divide through by negative 1, this one will be x. And because we are dividing through by negative 1, the sign will change. And when you divide here by negative 1, it will be negative 5. So it's the same as this, x is greater than negative 5. This one means x is greater than negative 5. So it's the same as x greater than negative 5, right, isn't it? And then when you come here, this same x is less than 5. Right, isn't it? So this same x is less than 5. So this will be the solution. This will be the solution to this problem. Right, isn't it, viewers? Now let's look at another example. Example 2. Let me do this one. You can give me something like this. The absolute value of 2. This one is 2. The absolute value of, say, x is greater than or equal to 3. When I ask to solve something like this. Now, from the definition of absolute values, you can say that x is greater than or equal to 3. That's the first one. That is if x is greater than or equal to 0. Now, or what about if x is less than 0? If x is less than 0, then it means that the other value will be negative x. And this they are saying is greater than or equal to 3. isn't it? So we have something like this. Now let's look at what we can do here. Here, this one will be, if you write 2 by negative 1, this one will be x, and then the sign will change less than or equal to negative 3. So we have it this way. Let's see if we can combine these two. X is less than or equal to negative 3. Isn't x is less than or equal to negative 3. And they're saying that this x is greater than or equal to 3. So this x is greater than or equal to 3 this way. Now, does this make sense? This does not make sense. You cannot get the values of x that will satisfy this inequality this way. The negative values are here and the positive values are here. So you can't get the values of x that will satisfy this. So this means that we cannot combine these two answers. You can't combine them. So if you cannot combine, then what you can say is that x is less than or equal to negative 3 or x is greater than or equal to 3. Yes. For example, let's look at this one. If you look at this one, if you pick a value which is less than or equal to negative 3, for example, if you pick negative 3, you put it here, the value of negative 3 will be 3. You see, and that is equal to 3. So the condition holds. Now, if you pick negative 4, you see it? Because you are saying that the answer here should be less than or equal to negative 3. So you pick negative 4, you put negative 4 here, the actual value of negative 4 is 4, and that is greater than 3. So this one holds. So this is true. Now when you come here, if you pick 4, or let's pick 3, if you pick 3, the actual value of 3 is 3, and it's equal to 3. So the equality condition holds. Now if you pick 4, the actual value of 4 is 4, and it's greater than 3. So it holds. So this is the solution. And you have seen that here, in this case, we can't combine the two solutions. So so the solution is x is less than or equal to negative 3, or x is greater than or equal to 3. Okay, now let's look at the next question. We have to move gradually. 3. It can also give you something like this. The value of x minus 2 is less than or equal to 4. It can give you something like this. Now, this one is going to be this. Look on the board. First of all, if the whole of this is positive or greater than 0, then the actual value will be x minus 2. That is, if x minus 2 is greater than or equal to 0, then the actual value will be x minus 2, the same thing, what I have been given. So this is less than or equal to 4. So if you solve this one will be x is less than or equal to, this one go there and add, it's less than or equal to 6. Or, in a situation whereby x minus 2 is negative, to get the actual value, you have to what? Negate it. So it means that in that case, the actual value will be negative of the whole of this, x minus 2. And this is less than or equal to 4. Now, if you expand this, it's going to be negative x plus 2, negative 1 times negative 2, positive 2, less than or equal to 4. So this one will be negative x, less than or equal, this one, these two go there and subtract. That is 4 minus 2, that is 2. Now let's divide through by negative 1, that will make this one x. And because we are dividing through by negative 1, the sign will change to greater than or equal to, this one will be negative 2. Yes, because we are dividing through by negative 1. So you have it this way. Now, so what this means is that, x, this x, you are greater than or equal to negative 2. Let me write this one well. Isn't it? And this same x, look at it, is less than or equal to 6. So this one makes sense. It makes sense. So this will be the solution to this question. Now, if you pick a value here, if you pick, say, 6, which satisfies this inequality, you pick 6 and you put 6 here. 6 minus 2 will be 4. The value of 4 is 4, and it's equal to 4. So the equality condition goes. If you pick, say, 5, if you pick 5, you put 5 here, 5 minus 2 is 3. The value of 3 is 3, and it's less than 4. So any value which satisfies this one will satisfy this. So this is the solution. Okay, let's look at the next question. The value of, say, 2x minus 6 is less than or equal to 4. can give you something like this and ask you to solve for x. Now, if 2x minus 6 is greater than or equal to 0, what this means is that the answer value will be 2x minus 6. So 2x minus 6 is less than or equal to 4. So 2x is less than or equal to 4 plus 6, that is 10. So x is less than or equal to 10 over 2, and that is 5. That's the first case. Now the second case is that if 2x minus 6 is negative, to get the answer value, you have to negate everything. So negative of 2x minus 6, isn't it? Is less than or equal to 4. Negative 2x plus 6, that is when you expand, it's less than or equal to 4. So negative 2x is less than or equal to 4 minus 6. When this 6 crosses, it will be negative. So it will be 4 minus 6, that is negative 2. Now we are dividing through by negative 2. So this one will be x. And because we are dividing through by negative, the sign will change to greater than or equal to 1. So we have it this way. So the solution now is x, this x, is greater than or equal to 1. Look at it. X is greater than or equal to 1. That is exactly what I've written here. Greater than or equal to 1. And this same x is less than or equal to 5. So this will be the solution to this question. It's not difficult at all. It's not difficult at all. So let's look at question number 5. Answer value of 6x minus 7 is less than or equal to x plus 3. Yes, let's look at this one. Now, if 6x minus 7 is greater than or equal to 0, then what this means is that the answer value will be 6x minus 7. So it will be 6x minus 7 is less than or equal to x plus 3. Are you seeing it? And then if you work this one, let's bring this to this side. That will be 6x minus x is less than or equal to 3 plus 7. 5x is less than or equal to 10. X is less than or equal to 2. Yes. Now, so this is the first condition. The second condition, if 6x minus 7 is negative, then its answer value, so this is all, its answer value will be negative of 6x minus 7. And this is less than or equal to x plus 3. Now, if you expand this, negative 6x plus 7 is less than or equal to x plus 3. Now, what this means is that if you take this to the other side, that will be negative 6x minus x is less than or equal to 3 minus 7. Isn't it? This is negative 7x is less than or equal to negative 4. Let's divide 2 by negative 7. So this one will be x is less than or equal to. Because we are dividing 2 by negative 7, the sign will change to greater than or equal to. Isn't it? So, and then this one will be 4 over 7. Because we are dividing 2 by negative 7. Negative will cancel negative. So you have it this way. So let's check if we can combine these two answers, this one and this. So we have it this way. X is greater than or equal to 4 over 7. Greater than or equal to 4 over 7. Look at it. You see that the x is pointing to the 4 over 7. It's the same thing here. And this same x is less than or equal to 2. Yes. So this is the solution to this question. So viewers, it's not difficult at all. Yes, because I'm introducing you, I don't have to be selling you so many things. Now let's quickly look at the following and then bring this lecture to an end. If x and y are real numbers, if x and y are real numbers, yes, if x and y are real numbers, you can write it this way. Then the following statements are true. 1. X is less than or equal to the other value of x. And negative x is less than or equal to the other value of x. Yeah, this is true. Now, if you pick, say 2, isn't it? 2 is less than or equal to the actual value of 2. The other value of 2 is 2. And you can see that 2 is equal to 2. So this is true. If you pick, say, negative 2, if x is negative 2, and if you put negative 2, the other value of negative 2 will be 2. And this is greater than negative 2. Are you seeing it? If you pick 0, because I said that x should be a real number, if you pick 0, either value of 0 is 0, and this is equal to 0. So it's true. Now let's go to this side. If you pick x to be, if x is equal to say 5, then when you come here, this one will be -5. And you are saying that, yes, and the other value of this 5, because the x is 5, is 5. And it is true that 5 is greater than -5, or -5 is less than 5. What about if x is equal to -4? If x is equal to -4, then when you bring it here, it will be negative of -4, and that will be 4. When you find the absolute value of -4, it will be 4. 4 is equal to 4, and it holds. Isn't it? It holds. Now, if x is equal to 0, if x is equal to 0, then this one will be negative of the x value, and 0 cannot be negated, so it is still 0. Isn't it? And the other value of 0 here is 0. 0 is equal to 0. So it means that this is true. This is true. 2. Absolute value of x plus y is less than or equal to absolute value of x plus absolute value of y. This is also true. Yes, you call this one the triangle inequality. Triangle inequality, this one. If x is equal to say 2, y is equal to 3, and 2 plus 3 here will be 5. Absolute value of 5 is equal to absolute value of 2, which is 2, plus absolute value of 3, which is 3, and that will make it 5. So it is 2. If x is equal to 2 and y is equal to -4, if you add the 2, that will be -2. Absolute value of -2 will be 2. Now when you go to this side, absolute value of 2 is 2, plus absolute value of -4, which is 4, that is 6, and 6 is greater than 2. Isn't it? So it is true. This is true. Yes, if you use MS to check, you see that it is true. It is true. Okay. Now let's look at 3. 3. You also have this absolute value of x, y. This is the same as absolute value of x, absolute value of y. If x is equal to say 2, y is equal to 5. 2 times 5 is 10. Absolute value of 10 is 10. Now, absolute value of 2 here will be 2. Absolute value of 5 will be 5. 2 times 5 is 10. And it's true. Isn't it? Now, if x is equal to say -3 and y is equal to 4, -3 times 4 will be -12. Absolute value of -12 will be 12. Now, when you come here, absolute value of -3 is 3. Absolute value of 4 is 4. 3 times 4 is 12. So it is true. Isn't it? Now, if x is equal to 0, y is equal to say 1. X times y will be 0 times y, or 1. Do you see it? And that will be 0. Absolute value of 0 is 0. When you come here, absolute value of 0 is 0 times this one, absolute value of 1, which is 1. 0 times 1 is 0. So 0 is equal to 0. So this is true. Isn't it? Yes. This is true. But you can prove this rigorously. Okay. 4. Absolute value of x over y is equal to absolute value of x over absolute value of y. Isn't it? For y not equal to 0. If y is not equal to 0. This is true. Isn't it? Let's check. If x is equal to say x is equal to 6, y is equal to 2. Then 6, that is 6 over 2. That is x over y will be 6 over 2, which is 3. The value of 3 is 3. Now, as the value of x, which is 6, so as the value of 6 will be 6, divided by the value of 2. And that will be, which is 2. So 6 divided by 2 is 3. So 3 is equal to 3. Isn't it? If x is equal to say -4 and y is equal to 2, -4 divided by 2 will be -2. As the value of -2 is 2. Now when you come here, as the value of -4 is 4. divided by absolute value of 2, which is 2. So 4 divided by 2 is 2. So this is true. Yes, this is true. And we are saying that y should not be equal to 0. If y is not equal to 0 and x and y are real numbers, then this is true. And then lastly, 5. Absolute value of x is equal to absolute value of x. Now what this means is that when you have the absolute value of a real number, finding the absolute value of that number whose absolute value has been found will not change anything. It will still be the absolute value of the original number. Do you see it? For example, when you have to find the absolute value of, say, -5, it's going to be 5. Do you see it? So if I give you something like this, absolute value of -5, then it's going to be absolute value of, now when you find the absolute value of this, you are going to get 5. And if you find the absolute value of this, you are going to get 5. Do you see it? So you can see that this is the same as straight away finding this absolute value. Do you see it? Yes, you just find the absolute value once and it's okay, it's enough. Finding additional absolute values will not change anything. Do you see it? So this is true. This is also true. Okay, so viewers, let's quickly prove one of these. Let's quickly prove one of these and then say goodbye to this lecture. For example, let's prove this one, the second one, the triangle inequality. So, and bring this lecture to an end. So, what we have is x plus, absolute value of x plus y is less than or equal to absolute value of x plus absolute value of y. You see, you want to prove this one. Yes, you want to prove it. Now, proof. And I've told you that this is the triangle. This is known as triangle inequality. Triangle inequality. Yes. Now the proof. Now, if x and y are real numbers, this is if x and y are real numbers, this is, yes, they are real numbers, then x is less than or equal to the absolute value of x. Yes, and I've even given it to you. And y is less than or equal to the absolute value of y. This is true. Let me call this one inequality 1, and then this one inequality 2. This one 2. Now, inequality 1 plus inequality 2, if you try to add them, then you are going to have x plus y is less than or equal to absolute value of x plus absolute value of y. Isn't it? You have it this way. Now at this point, if you decide to take absolute values of both sides, then it's going to be like this. Absolute value of x plus y is less than or equal to absolute value of x plus this. This is, you are taking absolute values of both sides. Isn't it? So I've taken absolute value of this side, absolute value of this side. So you have this way. Isn't it? And this is the same as absolute value of x plus y. Yes, you are proving it rigorously. This is a general proof. If you are using the numbers, that's not a general proof. You are just using the numbers to confirm that they are really true. But if you are asked to come out with a general proof, this is how you should go about it. Yes, so the others you can try to get a general proof. Let's look at this one. Okay, so have it this way. And this is less than or equal to viewers. You see that I've told you that absolute value of x is the same as absolute value of x. This is. So when you try to find the absolute values of numbers whose absolute values are already known, then you are not doing anything. So what this means is that this one, if you find the absolute values of x and then y, then straight away this will not count. Do you say that is from here? And this is one of the properties I gave to you. Yes. So straight away from here, you can see that it is the same as absolute value of x plus absolute value of y. Use it as required, and this is what we asked us to show. So hence the result. So this is the proof. Use it. So this is very, very important, and it's coming from here. It's coming from here. Okay. Now, viewers, the absolute value of x is equal to x if x is greater than or equal to 0, isn't it? And negative x if x is less than 0. We can ask you to plot the graph of absolute value of x. This is, you can ask you to just sketch the graph of absolute value of x. So you can just do something like this. This is x. So the y will be equal to absolute value of x. I said if this is 0, this one can be say 1, one can be 2. This one negative 1, negative 2. Negative 1, negative 2. If this is 1, 2. Now let's look on the board. If you have 1, you want the absolute value of 1. Do you see it? Which is x value. Then the absolute value of 1 is 1. Here. Are you seeing it? The absolute value of 2, which is on the x, is equal to 2. Are you seeing it? So the graph of this one will be like this. Let me draw it well. And then this one will also be like this. What this means that absolute value of negative 1 is 1. You see? And the absolute value of, look at this one. This is, so when you draw or sketch the absolute value function, this is it. This is it. So now the absolute value of 0 is 0. That's why this point is 0, 0. Now the absolute value of 1 is 1. Are you seeing it? The absolute value of 2 is 2. The absolute value of negative 1 is 1. The absolute value of negative 2 is 2. So it will continue like that. So this is the graph of the absolute value function, this one. This is, you can see f of x equal to absolute value of x. This is the graph. So viewers, thank you very much for your attention. For more of these videos, subscribe to my YouTube channel.